How's it going, everyone? Real quick, just want to go over how I'm using 3.5 Sonnet to make my coding workflow more efficient and why I believe that Claude 3.5 Sonnet is a lot better when it comes to testing and CI/CD as opposed to just raw code generation and just using it and not making any modifications. So right here, this is the summary that I had from a previous conversation, and this is the program that I'm modifying. What I'm finding with 3.5 Sonnet is I'm using it so much, and even times when I'm not really using it that much, I'm still hitting the rate limits like very quickly. So what ends up happening is, I'm going through the conversation, we're going back and forth, and just coming up with ways to make the program more efficient. And then what's going to end up happening is it'll have this little message like right around here saying like, hey, this chat's kind of getting long and you're going to hit your limit quickly. So after that comes up, pretty much what I do is I have it generate a summary of the conversation, and then we move on to a new window right here, and then pretty much start the process over again. And over time, that really gets annoying because what ends up happening when you summarize that you really have to be specific and exact with all of the information that needs to be added into the summary. The reason why is over time, it is going to shift and it's going to leave out information. It might even add in information that's not necessarily applicable, or it's just giving out wrong information. So you really have to make sure that whatever is in the summary is exactly like your system specs, how your program is structured. Everything needs to be explicitly uh, told to 3.5 Sonnet just to make sure that it has the exact information in that summary. For example, even when modifying the program and just actually adding in some code to it, you have to make sure that it doesn't actually take out code, because sometimes when it's making modifications to small snippets of code, like maybe 12 or 30 lines of code, it'll sometimes take out sections of the code, or just shift things around in a way that it changes how the program operates. And again, that's not really something you want. You really want, when Claude 3.5 Sonnet, when you're asking it to generate ways to make the program more efficient, again, you're not asking it to change certain sections of the code. You want to make sure that it's actually just doing the task that it is assigned and not going outside that parameter. So one of the first things that it actually suggested to me was to use Ratus. One of the interesting things about Ratus is that it can be used to implement async await functions in your program. The downside of using Ratus is that it does need to have a connection always active in your program. So what basically means is if you have a program out there and you're using it and you're using Ratus, your system, your laptop, or whatever you're using to actually send information and data to and from the server, it needs to always be on like 24/7. So that's like one of the main downsides. This is pretty interesting right here. I literally just came across this a couple days ago, and it's just talking about them building a serverless version of Ratus. So now, when they're saying that it's serverless, they're not necessarily saying that it's literally like there's no need for like an external information and being sent back and forth. The main benefit is just simplifying the workflow and making sure that it's just a little bit easier to actually work with long term. So this right here is pretty interesting, using RQ without a persistent Ratus server. We can use RQ with a temporary Ratus server that only runs during the execution of your program. This approach provides the benefits of a distributed task queue without requiring a permanently running Ratus instance. So that's pretty useful. I didn't have enough time to actually go through and implement this into my program because I was under a really strict time constraint. But I definitely do want to see, go back to my program and see how much of a difference this would actually make. So basically what the program is a data retrieval program, and it takes in information from profiles for like small business owners, and then it takes that information, and then those small business owners can actually do like either cold email, SMS, stuff like that. It took about like a minute and a half to actually go through and parse the information. I'm not entirely 100% sure why this is the case, but it seems on my system I do have a lot of trouble with frameworks that are related to rerouting tasks from the GPU to the CPU. This right here is just an example of one of the problematic libraries that has really just been kind of a pain in the ass to deal with. So the DLL, the Dynamic Link Library, is a collection of small programs that larger programs can load when needed to complete specific tasks. So in theory, it does sound good. It sounds like something that would actually add to the efficiency of a program. However, just getting it set up and actually working with your program is just a massive pain in the ass. And literally, you can just go here and I just typed in this by itself, like no, like nothing else in it. And you can already just see just issue after issue after issue, like just errors. So I'm not entirely sure 100% why that's the case. I do want to do a little bit more research into that because it does, at least in theory, sound like something that would be pretty valuable. But at least for right now, it's just way too much of a pain to actually get up and running with your program. So something else that I can really appreciate with Claude 3.5 is just how effective it is when you're giving it the right prompts and the right way of asking it a question. So for example, if I were to just ask, Claude 3.5, just say, hey, I want to make my program faster and more efficient, give me some ways of doing that. That doesn't really help me out because number one, I'm not sure which strategy, which tactic actually will give me the most benefit for the least amount of work. Like, what's the most efficient way of making the program more efficient, the most time efficient, and like the most actual gains in efficiency in the shortest amount of time possible, right? But again, when you're prompting it correctly, when you're asking the right questions, you get results like this. Not only am I getting multiple strategies onto how to make the program more efficient, it's also giving me some of the benefits and the drawbacks of it as well, just to make sure that I understand fully what is going on and which strategies are not going to have the biggest impact, or which strategies are just going to take so much time to actually make it work with the program that's not really going to be worth it to actually implement it on any type of large scale. As you can see here, these are just some of the considerations that I put out, just some basic overviews of how some of these strategies operate. So for example, right here, we have resource uses, multiprocessing, and process pool executor use more system resources, memory, and CPU compared to async, which might be a concern on resource constrained systems. So the CPU and the GPU on my system are pretty decent, so I don't really have that concern. However, when it does come to programs or functions or libraries that tend to offload tasks again from the GPU to the CPU. For some reason, it just doesn't work well in my system, so I tend to stay away from things like that. And to be honest, I think my GPU is decent enough to where like 80 to 90% of tasks can just be handled specifically in the GPU. So that's just what I usually go for anyway. I have an RTX 4070. So it's not necessarily like the most cutting edge or like the most insane GPU on the market, but it's definitely pretty decent in the grand scheme of things. So just on a quick side note, this is actually the chart that I use to decide which GPU that I actually wanted to buy. Now I know that, the actual FPS in games is not necessarily like the most, scientific way of doing it or the most, accurate way of choosing a GPU, but it's just something that's, quick, it's simple, it's easy, and it just shows you at a glance, the performance in general of these GPUs. So as you can see, the RTX 4060, while it does lag behind most of the pack up here, still in general compared to most of the other GPUs on the list, still holds it up. It still holds its own, and it's not necessarily as bad as some people would make it out to seem. See right here with the 4060 Ti, it does beat that threshold of 150 frames per second, so that's pretty decent. RTX 4070, which is, I would say, about maybe 170, 178 frames per second. So, still, again, it's pretty strong, pretty decent. It's in that upper percentile when it comes to GPUs. And then you have really the last like 5 to 6 GPUs up here. So you have the RTX 4080 Super, 4070 Ti, 4070 Ti Super, this cluster right here, where at a glance, it doesn't seem like there's much of a difference in performance, but when you actually go and you actually watch the videos and some of the breakdowns on the difference in performance between the 4070 and the 4070 Ti Super, at least when it comes to VRAM distribution, is actually a pretty decent difference between the VRAM in the 4070 and the Ti Super, which the reason why you need VRAM primarily, at least from my perspective, is for machine learning tasks and just actually self-hosting the models on your system. If that's something that you want to do, which is something that I definitely want to do, just having as much VRAM as possible is going to be pretty much one of the most important things that you can consider when buying a new laptop and a new GPU.